So welcome to the clinical pharmacology lecture. Today's topic is Introduction to Toxicology, Occupational and Environmental. So we live in the uh, modern society and in modern world that is full of the chemical compounds, and we inhale them, digest them, and also absorb some of them through the skin. So and Toxicology is a science that deals with all chemical agents on all living systems, like not only humans but animals, plants, and also the water, soil, air, etc. But in medicine, we mostly are concerned of the humans, and that is why uh, the medical toxicology is primarily concerned about the effects of these compounds to humans, and also about the safety and hazard associated with the use of these uh, compounds. So there are several types of the toxicology, and the occupational toxicology deals with the chemicals found on workplace, so mostly the uh, uh, special plants and so here actually, like in this picture, it's a metal producing plant and metallurgy, and the major goal of the occupational toxicology is to identify the acute and chronic diseases that may occur in the workers, and also protect these workers, like this man is protected with the mask and also the helmet and the clothes and the gloves, and protect them from these chemicals, so they can work safely and also prevent the absorption of the harmful chemicals through the skin, air, or the ingestion. And also the occupational toxicology make a surveillance of workers and uh, uh, make a regulatory limits and guidelines uh, to establish a safe environment, safe air concentrations for chemicals that can be found in the workplace. So, and there are many governmental and non-governmental organizations that make guidelines and the limits for the uh, concentration of these compounds at workspace. So, and the next part is the environmental toxicology, and environmental toxicology deals with the uh, impact of chemicals present in the environment. So, and what we mean when we talk about environment, it is the air, uh, water, and soil. So, and also other types of the pus, but mostly air, water, and soil, because these are the main sources of the pollution. And humans are actually the main interest of the in the medicine, but also animals and plants are also or suffer from these types of the pollution, especially the plants. So uh, and uh, air air pollution is mostly the uh, results of the industrialization and the development of the technology and also urbanization, and the this also contains the agriculture, pesticides in food that is grown on the fields with that use pesticides, and then also the food products that may be processed products. And there are a number of agencies that regulate the air contamination, like the Ministry of the uh, uh, Agriculture and the Ministry of Environmental Protection, and many other agencies. And the amount of the uh, allowed contaminants concentrations is also fixed with these organizations. And many countries have some regulations for the air contamination that should be met by the organizations that may produce, for example, produce the vehicles or produce the chemicals. And also the same in the agriculture, there is an acceptable daily intake of the chemicals from food that will not increase the risk of the diseases. So, and then there is also ecotoxicology, and ecotoxicology is concerned on the effects on populations and communities. So, do you remember this picture from the botany?
Yes.
So, actually, we studied the levels of organization, and then
Mm-hmm.
uh, why you study this, that because you need to know what is a population and what is a community. So because toxicology deals, ecotoxicology deals with the populations and communities of living organisms in a specific ecosystems. So, and that includes the transfer of the chemicals and interactions with the environment, and if traditional toxicology concerned about the one person, like specific individual, like human, ecotoxicology is concerned on the whole living organism, the whole ecosystem. So, and sometimes even the whole biosphere, that is the Earth itself, but mostly ecosystems. So ecologists usually talk about ecosystems or communities at least. Okay, so then we move to the definitions in toxicology, and the first definition is hazard and risk. So what is a hazard? Hazard, that is something that can harm you in case of you like are close to this hazard. So like, for example, this is a person and this is a shark. Unless the person will not swim in the water, there is no chance he will be eaten by the shark. So this is a hazard. That is why if there is a sign that sharks can be seen in the water, you should not swim there. And then the risk is a likelihood of the hazard. So like, if you swim in this water, there is, for example, 50% of the chance that shark will eat you. So that is the risk. So and what toxicology do, toxicologists will assess hazard, uh, and uh, and they will tell that this hazard is present here, and then they will also evaluate the risk. So if the risk is high or low, and also they de depending on the frequency of the occurrence of the series, and they will estimate the data from the different observations, and then uh, will estimate the limiting factors for this risk. So then there are routes of exposure. So routes of exposure are very close to the routes of administration. So same as with the drugs, there is oral, then there is the uh, uh, through the uh, through the lungs, so the breathing, and also through the skin. So absorption through the skin is also possible. Most of the toxic agents will go through the uh, uh, through, by eating, so through the uh, uh, inhalation or the uh, through the food. So these are so through the food and air. So these are the main routes of exposure, and then dermal contact is less common for the toxins, and that is why the primary prevention for the uh, exposure is to prevent these routes. So, for example, don't allow workers to eat at the workspace, and then use a mask or filter air filters to decrease, so to prevent the inhalation, and then also cover the skin with the protective clothes at the workplace to prevent the absorption through the skin. Uh, so then the next one is duration of exposure. So there are two types, like in as the types of diseases. There is acute disease and chronic exposure. So acute exposure is usually one-time exposure with a high dose, and this will lead to the major damage. And then the chronic exposure is a low concentration and repeated exposure, like for example smoking, uh, and so acute exposure is usually intoxication with the poison. And so acute exposure can also last for several days, but not more than not more than 2 days, and this will be acute. And the chronic is usually several months and even years, and can also be from accumulating in the tissues. Uh, then so and the most important environmental considerations include the uh, the different toxicants, and knowing the chemistry of these intoxicants, we can predict the impact to the environment, and depending on the stability of the substance and mobility through the air, water, and soil. So, and uh, most chemicals are poorly degraded, and therefore they exhibit a environmental accumulation, and the most common chemicals that accumulate are polyfluorinated biphenyls. So these are double phenyl with the fluorine residues somewhere in any position here. So, and these are used in the production of the energy transformators. So when the electricity comes, so in the electricity transformators that are used at the station. So when high voltage electricity is converted to the low voltage electricity, they use special transformators uh, to save the energy. So these transformators are old ones have these polychlorinated biphenyls, so that may contaminate uh, the air because when they are refueled or degraded. Then also organofluorine pesticides are also poorly degraded, uh, and they are lipophilic and accumulate in the body fat, resulting in the tissue residues, and they lead to the chronic intoxication, and also they can be incorporated in the food chain, that can result in biomagnification and bioaccumulation. So what is a biomagnification? So because of the humans are located at the highest level of the food chain, so uh, we all the animals that will absorb the poisons during their life uh, can accumulate uh, in these animals. So because animals also can eat like large fish can eat small fish can eat also plankton. So and they eat everything that is accumulated, all poisons that are accumulated by this phytoplankton. Then large fish will eat small fishes that also accumulate. So uh, and then the people will eat this fish that is with that accumulated the poison during its whole life. So eventually, for example, here the mercury level is presented in fish, and also the polychlorinated biphenyls accumulate like in the ocean because of the uh, uh, so the ocean is contaminated by the industry, and when the uh, toxins pass through the food chain, they can accumulate the level of for example, the level of the mercury can increase up to 50,000 times, and then the people will consume this polluted fish and then can have a toxic the intoxication. And so this is a bio magnification, and bioaccumulation is actually the accumulation that uh, makes place in the single organism over the time because of the lifespan of these organisms. So like for a large fish that lives for several years, like for 10 years for example, and that for example fish and shellfish absorb the mercury directly from the environment, and uh, it remains in the fish's body for long periods, and this leads to the mercury build up, and then humans that eat this fish will also will, end up with the intoxication with the mercury. So despite we are not using the mercury uh, thermometers now and also lamps, so the mercury intoxication can be seen from the fish. So because still there are plants that pollute the lakes, and the lakes then go to the ocean, and then fish will receive this mercury from the ocean. And uh, so the uh, so this is a biomagnification and bioaccumulation. So then let's speak about the specific chemicals, and also we will start with the air pollutants, because the air pollution is the most important and most dangerous type of the pollution. And there are six main air pollutants exist in the atmosphere. So mostly from the vehicle exhaust, and also from the chemical production. So first is the particle matter, that is the small pieces like dust. They are uh, can be seen from the rubber of the vehicles and also from the internal combustion engines. Then second is sulfur dioxide, then nitrogen oxide, ammonia, volatile organic compounds, mostly carbon monoxide, and also methane. Secondary air pollutants are the particle matters and ozone, so those are formed in the atmosphere uh, by the chemical reactions from the primary pollutants. So the sources of these pollutants include the uh, vehicles, industry, generation of electric power, like the uh, burning of coal, and also gas, burning of the natural gas to obtain the energy at energy plants, space heating, and also disposal. Uh, and sulfur dioxide, for example, are resulting from incomplete combustion of coal, uh, and the uh, breathing in the particles of the sulfur is connected to the respiratory diseases, including the uh, bronchitis, chronic obstructive bronchial disease, and bronchial asthma, and lung cancer. And because of this, the environmental protecting agencies applies standards for every of these substance uh, for to protect. And for example, these are the threshold limit values for some common air pollutants and solvents. So for example, if we take the sulfur dioxide, the ppm, that is the parts per million, should be 2. So and there are actually different agencies that so apply, and then uh, for uh, different agencies and agents, they may from country to country they also can differ sometimes. And the most important and most dangerous of these uh, air pollutants is carbon monoxide. And carbon monoxide is a colorless, tasteless, odorless, and non-irritating gas, and is mostly produced by the vehicles uh, and also some plants. So, and usually is the result of the incomplete combustion. So, like in internal combustion engines in vehicles, and also in plants that burn coal. So the average concentration of carbon monoxide in atmosphere is 0.1 ppm. So, for example, if we will stay in heavy traffic, the concentration of carbon monoxide can be up to 100 ppm. That is 1,000 times higher than the normal ppm. So, and if we see at the recommended threshold limits of the carbon monoxide, it is 25. So that means that if we stay in heavy traffic, we exceed the recommended level 4 times. So and that will result in the adverse effects. So the and adverse effects include the adverse effects can include anything from low concentration, it will be headaches, and then at high concentration, it will be nausea, dizziness, breathlessness, and at the uh, toxic concentrations, so like for example, at about 50% from the by volume, it can lead to the collapse and also loss of the consciousness. So this this actually happens at concentrations like the about 1,000 ppm. So but at heavy traffic, like actually we have 100 ppm. So like we can feel dizziness and nausea. At normal actually we have only 0.1 ppm. So actually it's normal concentration. So and at this normal concentration, the carboxy monoxide has the same saturation with the oxygen. So because the carbon monoxide will connect with the oxygen, will bind with the oxygen, with the hemoglobin, and prevent the binding of oxygen with the hemoglobin. That will decrease the oxygen transfer to the tissues, primarily to the brain and heart that demand much oxygen. And for example, in the non-smoking adults, the carboxyhemoglobin levels are less than 1%. So, and in those people that smoke regularly, the amount of the carboxyhemoglobin can be up to 10%. So, like, depending on how frequently person will smoke, like the light smokers will have 5, heavy smokers will have 10%, and then this is actually very close for the it's closer for the person smoking the 1,000 ppm CO2 that have a 50% uh, amount of the carboxyhemoglobin, and that will lead to the collapse. So in the 0.1% carbon monoxide is actually very toxic, so a very high concentration. So the normal concentration is 0.1 ppm, that is parts per million. So this is actually parts per 1,000, so 1,000 times higher concentration. Uh, so uh, the treatment for the carbon monoxide intoxication includes the oxygen, so pure oxygen, 100% oxygen inhalation that can be done at the room atmosphere, at the room uh, pressure, or in a barrel camera. So this is special camera that uh, will increase the uh, pressure, and the pressure will be hyperbaric that will increase the oxygen concentration in the lung. And so in this camera uh, the treatment is faster, like can be about 20 minutes, and at the room pressure the treatment is about uh, 4 hours of the oxygen inhalation. So in this camera it can be only 20 minutes of oxygen inhalation to reduce the concentration of the carbon monoxide uh, carboxyhemoglobin that is results from the binding of carbon monoxide to the hemoglobin. And even after this procedure, it's not complete recovery. Some patients may have some prolonged adverse effects that results from the brain and heart damage. So that is all for today, and thank you for your attention, and we will continue the next week. If you have any questions or comments, then feel free to leave them below.